Good day, friends. Today we have with us a very well-known curve. We see it so often in various ways and various forms. For example, look at the threading of the screw. And the threading goes like this. That is what we call a helix. The same shape you can see here in a coil or a spring. Here is a spring, and you can see that the shape is again the same, a helix. Also, the outer ear has the shape of a helix. In biology, when we talk about DNA, we have to talk about helix and a double helix. We'll see that a little later. We want to see this helix. It's very well known, but it has a property which very few people know. So we want to talk about this property of this well-known curve. But first, what is this curve mathematically? Well, mathematically it is like this. As you can see here, it is like we are reminded of a spiral ladder in many malls, in some small houses also, in order to save space. This looks just like that. And that ladder is also a helix. Now, mathematically, what happens is this, that there is a straight line here, line segment rather, and in the center you have an axis. In the center you have an axis and you have a line segment, and it is perpendicular to this axis. Now, it moves in such a way that not simply in the same plane. It goes up and rotates, up and rotates, up and rotates, and every time it is perpendicular to this axis. You can see here the first line segment, the bottom one is this one, then the next one is a little bit higher and it has moved by this angle, the next is a little bit higher and moved by the same angle. Now, while it moves, three things are involved. One is, it is always perpendicular to the axis. Secondly, the ratio of the height and the angle of rotation every time has to be the same. That means they're proportionate. So, if you take 1 cent here, I have taken equal intervals here and equal angles. But if we skip one in between, the interval will be double, the angle will be double. So the proportion is the same. And that is how you get a helix. Now, this helix has a very nice property, as I told you, very little known, and it is known as geodesic. So first I will tell you what a geodesic is. Geodesic is the shortest distance between 2 points. Well, we know that the shortest distance between 2 points is the length of the line segment joining them. That's in a plane. Here it is fine. But if I talk about the sphere, or if I talk about this cylinder, even in the cylinder, if the 2 points are one below the other, it is easy, the line segment. But one point is here and the other point is here. Then you can't have a line segment. In that case, helix is the curve of geodesic, or it is the shortest distance between 2 points on a cylinder. And this is how we demonstrate it. Now actually, I want to take 2 points on the cylinder, but I will not mark them on the cylinder. I will mark them on this plastic. So we can see it. Okay, so this is take one point on the cylinder, say here, and another point, say here. Now you can see that they are not one below the other. What we do is, actually we have wrapped the whole cylinder with a plastic, but I am taking only this much piece. Now cut the plastic and you know it will open up into a plane. And once you get a plane, we are very happy because we know what to do now. Now on the plane we know that we can join these two line segments to get the shortest distance. So we have joined, as you can see here, we have joined the 2 points which we had marked with a straight line. And now you can see that if you put them back on the cylinder, the 2 points are on the cylinder, and as you can see, the straight line coincides with the helix. Or in other words, the straight red line was the shortest distance between 2 points. So the helix, part of the helix between these 2 points will be the shortest distance between these 2 points. Well, that is very interesting and difficult to believe, but I am sure the model must have convinced us, and we have learnt a very nice property of a well-known curve. Now before we end, I would like to show you the double spiral we had referred to. This has been made for home decoration, but as you can see that they are all equidistant and moving with the same angle, rotating with the same angle. And at the two ends of each line segment, if you join them, you will get a double helix. One is this black and the other is its opposite one, and that is white. And that is what we refer to for ADNA. Now in order to make this, that is the second thing we want to do, you can just take a broomstick and some pins and poke them perpendicular to the broomstick and moving at the same angle, upwards at the same angle. Here what I have done is that in this cylindrical jar, I have taken a cycle spoke and cut straw into exactly the length of this diameter of this cylinder. And in the middle, I have put a hole and all my straws are here. And then they have been placed equidistantly and rotated to give the correct angle, and that gives you the helix. Okay, you can make it and see the different properties. Thank you.